be equal to 0. So if x is negative 1, the bottom of this fraction is equal to 0. So I don't get to include this one little point right here on this line where x is negative 1. It actually, your graphing calculator again doesn't do well. It will not show the hole on the picture, but it will show the hole when you do the table. At negative 1, it says error. So, and that's its way of showing the hole. Okay, so all of this to tell you how we're going to figure out where the holes are, where the vertical asymptotes are, and where the horizontal asymptotes are. Okay, so if I have a hole or if I have a vertical asymptote, those are called points of discontinuity. So in this one, I have a point of discontinuity at x equals negative 1. On this one, I have a vertical asymptote. I have a point of discontinuity. This one's also at x equals negative 1. I have points of discontinuity at x equals negative 2 for an asymptote and x equals positive 2 for an asymptote. I don't have any points of discontinuity in this one. So let's figure out how you find points of discontinuity. So you get a point of discontinuity I guess points of discontinuity happen when the denominator equals 0. Okay? For example, if I have y equals x plus 2 times x minus 1 over x plus 1, I set the denominator equal to 0. I solve for x. X equals negative 1. I have a point of discontinuity at x equals negative 1. If I have y equals 1 over x squared minus 4, I set the denominator to 0. X squared minus 4 equals 0. I solve that for x. Oh, that's x squared equals 4. Take the square root of both sides, and I get x equals plus and minus 2. And we're only looking for real number answers. If I get imaginary answers, they're not points of discontinuity, because we're looking for points of discontinuity in the real number system, in the the graphs in the xy plane. So I have points of discontinuity at x equals 2 and negative 2. Yes, ma'am. Okay, so hole or asymptote. Okay, so the rules for a hole: if you have the same 0 in the numerator and the denominator, denominator, you get a hole. So let me go back to what my example was. X plus 1. So if I have y equals x plus 1, times x plus 2 over x plus 1. I have a point of discontinuity when x plus 1 equals 0, x equals negative 1. If I put negative 1 into the top, will I get another 0? Oh, well, let's just look at the zeros for the numerator of this fraction. The zeros for the numerator are x plus 1 equals 0. Oh, x equals negative 1. Oh, I have the same problem on the top and the bottom. I have the same 0 in the numerator and the denominator. That gives a whole at x equals negative 1. Yes?
But why don't we do x plus 2?
My wholes only happen when my x's give me a 0.
I mean, like, why don't we cancel x plus 2?
Okay. So x plus 2 won't give me... okay, let me do x plus 2. X plus 2 equals 0. X equals negative 2. Do I have a 0 of negative 2 in the denominator? No. So that one is not going to give me a whole or an asymptote. So the wholes and the asymptotes, let me go back to my pictures. The wholes and the asymptotes are when I get 0 in the denominator of the fraction. That's where my wholes and asymptotes come from. So I don't really care about the numerator except when I have to decide whether it's a whole or a asymptote. Okay? Yes? Oh, gosh. When did I write that there's a whole at negative 1? All right. Jeez. All right. So I get a whole if I've got a similar 0 in the numerator and the denominator. The same 0 in the numerator and denominator. Okay? Otherwise, it's an asymptote. So it's a vertical asymptote if it's not a whole. So let's go with y equals x plus 1 times x plus 2 over x plus 3. Look at the zeros for the denominator. The 0 for the denominator is at x equals negative 3. The zeros for the numerator are at negative 1 and negative 2. There's no common 0. So that x equals 3 is not a whole, it's a vertical asymptote. Okay? Rule number 3. So we got wholes, we got vertical asymptotes. Now we need to deal with horizontal asymptotes. And they're a little trickier, but you just got to remember the rule. You ready? You get a vertical asymptote okay. So there's 3 rules to follow here. Vertical, horizontal. Sorry, we already did vertical, didn't we? I am just like, my head is just like, yeah, really. We did vertical asymptotes, did we? Yes. So now we're on to horizontal asymptotes. All right. You can only have one. Can't have 2 or 3, but you can have as many vertical asymptotes as you want. If you want to make out of this one. Okay. So now we have to look at the degree of the numerator versus the degree of the denominator. Remember, degree, if I have a